So students, we have seen what exactly IAT inscribed angle theorem is, what is TST tangent secant theorem, and with the base of IAT and tangent secant theorem, we have learned a new topic. We have combined together, we learned something new which is called as angles formed in alternate segment. From my side I stated as a FAS. Now students, we just need to remember one thing. In order to apply a FAS, angles formed in alternate segment, just keep in one thing in mind, that for that stuff to be applied, you need to have an inscribed angle, you need to have a tangent secant angle, then and then only you can say both these angles are congruent. Let me just refresh my concept, what I have stated up now. I have stated that you need to have an inscribed angle, you need to have a tangent secant angle. So you can say this is the tangent secant angle, this is the inscribed angle. You need to have both of them for me to apply. These are congruent by a FAS. And I stated earlier that we shall solve one problem which can make you understand complete a FAS, how a FAS is applied. One more thing is what is needed before I start solving. I hope my student knows exterior angle theorem for triangle. If you all don't know, I shall once again explain you what the exterior angle theorem for triangle is. If this being the exterior angle, then the exterior angle of a triangle is equal to the sum of the remote interior angles. If I have to name it in numericals, then angle 1, this is angle 2, and this is angle 3. Then by exterior angle triangle theorem, I shall say angle 1 is equal to angle 2 plus angle 3. The exterior angle is equal to sum of remote interior angles 2 plus 3. 2 and 3 being remote interior angles. So in order to solve this particular sum, I require exterior angle theorem, and I shall make extensive use of a FAS. Let's see how this works out. Before that, let me tell you what the sum is all about. The sum says there are two circles of different area, but naturally they are of different radius. Two circles touch each other internally, and the point of contact is point M. Two circles touch each other internally at point M. Line AMB is a common tangent to both the circles. CD is any chord for larger circle. At the same time, if you see, CD happens to be tangent for the smaller circle at point N. As far as CM and DM are concerned, they are two chords. CM and DM are two chords of the larger circle intersecting smaller circle in points P and points R respectively. What we intend to prove? Angle CMN congruent to angle DMN. I haven't proved it. Let me see what we are supposed to prove. So what am I doing, students? I am just highlighting it with dotted circles. That angle CMN and angle DMN. These are the two things I intend to prove. I haven't proved it, but these are the two things which we intend to prove, is what I have highlighted with dotted circle. Now, we start off with it. Now, sums of this nature, let me tell you that one more thing from my side. Sums of this nature, I shall not write down the angles, all the angles, the name of a particular angle. For instance, if I have to name an angle, I shall not say CMA. What I'll do is, I'll make extensive use of numericals, whereby which the sum of this nature becomes very, very easy. Let's practice it out. Let's start the sum. I intend to prove CMN congruent to DMN. There is a small amount of construction. We just join NR. Segment NR. MNR. To start off with, if you just happen to focus for larger circle, I repeat, you need to focus on larger circle. Then for larger circle, what do you see? What becomes the inscribed angle and what becomes the tangent secant angle? Just happen to see this angle Is it a tangent secant angle for larger circle? Simultaneously, this becomes the inscribed angle for larger circle. So I say that angle 1 is congruent to angle 2. Angle 1 congruent to angle 2. So our proof starts over here. And I say for larger circle. It is angle 1 congruent to angle 2. What is the reason? Equation number 1. Reason I do say this as a fast. Absolutely on a parallel line, I need to focus for smaller circle. So for smaller circle, if you happen to focus on smaller circle, then this becomes the inscribed angle, and this whole becomes your tangent secant angle. Let me name it. So this is angle 3 and this is angle 4. This is angle 3 and this is angle 4. What can I say for smaller circle? I can say for smaller circle, angle 3 is congruent to angle 4. Angle 3 is congruent to angle 4. Equation 2. And again I say this as a fast. That is angles formed in alternate segment. Now, there is a simple way to understand the sum. Students, we need to find out CMN, or rather we need to prove CMN congruent to DMN. I don't know how I can prove this, but a very simple technique or a way to go with. How can I get CMN? How can I get CMN? Answer is very simple. If from angle 3, if I subtract angle 1 from angle 3, the complete angle, if I subtract angle 1, I shall get this angle. That tells me what is the next step I'm supposed to do. I need to subtract angle 1 from 3. So what I'll do is I'll say subtract equation 1 from 2. What I shall say, subtract equation 1 from 2. On doing so, I get angle 3 minus angle 1. Angle 3 minus angle 1. On the right hand side, I shall get angle 4 minus angle 2. Now let's check what is angle 3 minus angle 1. If you take in terms of naming, then angle 3, which is in total this angle 1 which is this, if I subtract it, eventually I lead up with CMN. So angle 3 minus angle 1 is nothing but angle CMN. Angle CMN. On the right hand side, let me keep it in numericals only. Angle 4 minus angle 2. Angle 4 minus angle 2. Let this be equation number 3. Now students, I have a very simple way to do so. I intend to prove CMN should be congruent to DMN. That is what I require to prove so. A simple technique from my side. What do I do is, I got equation in terms of CMN. What's the equation in terms of CMN I got? I got equation of CMN, or rather angle CMN is nothing but 4 minus 2. You know what we need to do now? We just need to have one more equation. Which tells us that even DMN should be 4 minus 2. I repeat what I said. I got equation 3 as CMN is equals to 4 minus 2. In order to get CMN is equals to DMN, a simple way to think is, okay, even if I prove DMN is 4 minus 2, then I'm done with my job. That even CMN is 4 minus 2, DMN is also 4 minus 2. Their RHS are same, therefore their LHS happens to be the same. So now we are into 4A of looking out how DMN can be proved equal to 4 minus 2. We shall focus on this section. Can I say 4 is an exterior angle for triangle NRD? I repeat myself, I reiterate myself, angle 4 is an exterior angle for angle NRD. So by exterior angle theorem, 5 minutes back I made you understand what's an exterior angle theorem for triangle. I shall say this as angle 5. So can I say exterior angle is equal to sum of the remote interior angles? Exterior angle is equal to sum of the remote interior angles. Having said that, I shall now say angle 4 is equal to 2 plus 5. Angle 2 plus angle 5. I got angle 4 is equals to angle 2 plus 5, but I always wanted 4 minus 2, so I bring this over here and I'm left with angle 5. So can I say that is angle 5 is equals to angle 4 minus angle 2? I went this, or rather we shifted angle 2 over here, so I'm going on the left hand side becomes minus, so it's angle 4 minus angle 2 is nothing but angle 5. Still, we haven't got DMN. Now we need to have a relation between angle 5 and DMN, because we got RHS as 4 minus 2. Now we need to have DMN and angle 5. If you just happen to say angle 5 and happen to look at DMN, which is this angle, DMN is nothing but this angle, just pay attention, this becomes the tangent secant angle, this becomes the inscribed angle. So now I can say also angle DMN is congruent to angle 5. What is the reason behind it? Let this be equation number 4, and the reason behind, let this be equation number 5, and the reason behind this is a fast. So with the help of equation 4, I got angle 5 is equals to 4 minus 2. But with the help of equation 5, DMN is congruent to angle 5. So can I say from 4 and 5, can I say from 4 and 5, it is angle DMN, it is angle DMN, which is angle 4 minus angle 2, which is angle DMN, is angle 4 minus angle 2. Let me give this as equation number 6. Now students, just pay attention to equation number 3. It was CMN, which was 4 minus 2. Now eventually we got DMN also as 4 minus 2. So one can write down from equations 3 and 6. I'm writing on the left hand side to make you understand. I'm writing on the left hand side to make you understand. Equation 3 is CMN, which is 4 minus 2. Equation 6 is DMN, which is again 4 minus 2. So from equation 3, let me just draw a vertical line. From equation 3 and equation 6, I can say CMN is equal to DMN. Or rather, if the question says congruent, then they are congruent. This is how we have proved CMN congruent to DMN. And this is how one can say a fast works out. This is a prima facie one of the case where a fast works out extensively. Hope you have understood. Thank you.